Next discrete distribution is the Bernoulli distribution. It is a special case of the binomial distribution with n is equal to 1. Before you dive into the Bernoulli distribution, I would suggest that you watch the binomial distribution videos first. This will help you better understand the model. So the Bernoulli distribution is the discrete probability distribution of a random variable which takes the value 1 with a probability of p and the value 0 with probability q. Let us see what is meant by the Bernoulli random variable. It is a variable that has two possible outcomes, which can either be a success or a failure. We know that if we add the probability of all the possible outcomes, it should give us 1. In this case, we have only two outcomes, either a success or a failure, which means that if we add success plus failure, we should get 1. In probability theory, we represent the success by P and the failure by Q, which means that if we take P plus Q, we should get 1. Normally, you're given the probability of the success. From the probability of success, we can find the probability of failure. We have Q is equal to 1 minus P. So we can see that the probability of a success is what? P. And probability of failure is Q, where Q is equal to 1 minus P. The Bernoulli distribution is a model where a single trial is conducted. That is, a single experiment is conducted. That is why we have n is equal to 1, a special case of the binomial distribution. In a binomial distribution, we can conduct an experiment several times. That's where n can take any value. We can perform an experiment 4 times. That's where we have n is equal to 4. We can conduct an experiment 5 times. That's where n is equal to 5. But if we conduct a single experiment, it is called the Bernoulli distribution. If x is a random variable with a Bernoulli distribution, then the probability of x is equal to 1 is equal to p. That is the probability of success. Probability of x is equal to 0 is the same as q, where q is equal to 1 minus p, which is the probability of failure. The probability mass function f of the Bernoulli distribution over possible outcomes k is the function p if k is equal to 1, 1 minus p if k is equal to 0. The function can also be written as p power k, 1 minus p power 1 minus k, for k an element of the set 0 and 1. So we can see that this function can only take values k is equal to 0 or k is equal to 1. The expectation value of a Bernoulli random variable x is expectation of x is equal to p, and the variance is pq or p bracket 1 minus p. To better understand this model, let us draw a probability distribution table. We know that our Bernoulli distribution can take only two possible outcomes. That is either a success or a failure. That is, we can either get a 0 or a 1. So our x can take 0 or 1. From the values of x, we can obtain the probabilities. We've seen that the probability of getting a 0 is equal to what? Q, the probability of failure. The probability of x equals 1 is what? P. So what can we actually understand from this distribution, from this model, is that we conduct a single experiment that asks a yes or no question, where such questions lead to outcomes that are Boolean valued, which means that our model can take only values 0 or 1, where the 0 is what? The failure or success. It can also means what? No or yes, false or true. From the distribution table, we can find the expectation. We know that to find the expectation of x, we take the value of x, we multiply by its corresponding probabilities, which means that the expectation is going to be what? 0 multiplied by q plus 1 multiplied by p. So we have what? 0 plus p, which gives us p. We've seen earlier that the expectation of x is equal to p. Next, we can find the variance. But first, we need to find what? The expectation of x squared. We take 0 to the square, multiply by q plus 1 to the square, multiply by p. We have 0 plus p equals p. Then the variance is p. You minus the expectation to the square, which is p square. So we have p bracket 1 minus p, which gives us pq. So there we have it, the variance and expectation of a Bernoulli distribution.